Okay, let's start with question number 15. Now, I just look at it and I can say, oh, this is algebra. This is an expression because there's no equal sign. Chapter 3. So, algebraic fractions. So, let me take you to the textbook first. So, chapter 3, question 15. Let me show you where. I took a page out. And if you look here, it's page 110. It's book 1. It is algebra, it's expressions, it's algebraic manipulation, algebraic fractions. Okay, maybe before I do this, I can just maybe focus on that rule. Okay, so the cancelling rules in algebraic fractions, it can only cancel out if it's one term over one term. Otherwise, it cannot cancel out. Okay, so I must do something to make it one term if it's, say, two terms. Now, if you can recall, I said it somewhere in the question papers. If I factorize something, an expression, I make it one term. If it's two terms, I make it one. Three terms, one. Four terms, one. Okay, so that's going to help me. I only cancel if there's a multiplication sign, okay, on top. You can cancel any top with any bottom, joined by multiply, as long as there are no plus or minus signs in the expression, unless they are in brackets and you can cancel the bracket. Meaning, say for example, you have x and you have x plus 1. You cannot cancel this x because there's two terms. There's one, there's two. But say for example, there is a x plus 1. And you can put, then that whole bracket can cancel that bracket. Okay. Now, this is the example I want to show you, example 24. Now, if you look at this example, I see two terms. But if I take out, okay, I can just put a bracket, that one. The bottom one, I can take out a common factor of negative 1. Okay. Because the problem was in this one that you see the A, do you see the A is there, it's positive, and there the A is negative. But if I take out negative 1, it becomes positive and that becomes negative, and I just swap that two terms around. And then it's almost like a copy and paste. As if it's a copy paste brackets, then you can cancel them out, and that's the answer. There's two terms, so common factor, no, but difference between two squares, yes, I see that. Trinomial, I factorized. Copy and paste brackets can cancel out, the rest just stay. So keep that in mind, page 110, and let's just go back to the question paper. Okay, let's just move down a little bit. And there you see it. So if I'm going to start, I'm just going to make it a bit bigger. Okay, so I'm going to look at this one and I'm just going to say, I'm going to factorize. So I can say x, I take out the common factor. Yes, you can put an equal sign, it's fine. And it's going to be 2x plus 1. Now, this is difference between two squares. Oh, I just don't like a line that's not so nice. Okay, so what I usually say, I say it's in group B. Okay, so I take the coefficient in front and the constant, and I break it up. But because I see 7, so it's somewhere I must come to 8 because I must subtract it. So maybe if I go 2 and 1, and I go 1 and 4, because that will be 8 minus, I must subtract. So, and that will give me 7 on the dot, correct my numbers, my factors. But then the biggest over cross product must get that middle sign and in front of this row. So that will be a negative. And if that is a negative, opposite signs the bracket, positive x, x. So do it here on this side. And then I'm just going to go back and I'm just going to say 2x plus 1, x minus 4. And do you see, it was 2 terms, 1 term, 3 terms, 1 term. But this cancel out. Oh, it's so nice if something cancel out. It's just a nice feeling. Please do not cancel that too, because there's 2 terms. So the answer is x over x minus 4. So this is counting 4 marks. So it seems to me they'll give 1 for, and they give 2 for that. And then if you arrive at the answer. Okay, that was not so difficult. Just know your factorizations. Then I'm on question 16. Okay, now this is just, I think, substitution. Very, very simple, but I like to, because find the values. V is 80 and they give. So if I want to take you, just showing you where it's in the textbook. It's question 16. Let's see where it is in the textbook. Okay, so it looks to me, it's on page 167. Do you see that? And that is algebraic representation and formula. So it's in the equation, okay, because it's an equation. And this is a far more difficult example, but the principle is just, I'm just going to make it smaller that you can see it. Okay, so the principle is just going to be the same. So if this is the formula and I'll give you the values, it's just basically putting it in. So all that I want to emphasize here, I like to put it in brackets. Why? So that if there's a sign, so in the place of u, where is u? Let's just see, u is 10, I put 10. In the place of t, where is t? 2, and I put 2. And I rewrite plus half, and in the place of a, I put 5, in the place of t, 2. And then I just calculate it and I get the answer. Very, very, very simple, and you are doing it from grade 8. Okay, so let's just go to the question paper. The question, that one was not so simple, the formula, but I think the question paper, the formula is very simple. Okay, so again, score marks. So let's just write, I prefer just the copying exactly the formula as it stands. Find the value of v when a is 5 and t is 12. Then I always put in brackets, because now it's not negative, but it could have been, and then you usually make mistakes. And then if it's in bracket, it's already indicating it's multiply, and I just say value of v is 60. And again, it's just 1 mark because it's really a grade 8 sum. And now make A the subject of the formula. And I want to take you again to the textbook where it... Okay, so in the textbook, subject of the formula is on, and I'm just going to make it a bit bigger. It's page 169, and actually there you will transpose formula, changing the subject. So formula written, so the single variable, the subject of the formula, is on the left-hand side of the equation. Everything else goes on the right side of the equation. Sometimes we need to rearrange a formula so that another variable is the subject. This process is called changing subject of the formula. You use it also in other subjects like physical science and that. Very important. Okay. So the one I'm going to go to is I'm just going to explain 50 because it's a very simple one that's in the question paper. So maybe I'll just start with 49. Make x the subject. So it's just like you isolate x. So you keep x and you take the 3 over and then you just swap the sides. Here I say make d the subject. Now what I usually tell learners, as soon as you see it's negative, then take it to the other side. So I take this one to the other side so that it becomes positive. Okay, there's the 9. Then I take the e over and it becomes negative. And then I divide 3, and I have the answer. Okay. The one in the question paper is very simple, but it's just, I think, a multiplication. So let's just go back to that one. Okay. So in this case, I must just see that question also. There it is. So as I said, it's just actually testing, I think, here, if you know what it is, changing the subject. So in this case, you're just going to divide by t, and you divide by t. And you will get a equals v over t. And I basically just swap the sides. So a equals v over t. So I put in v over t. And it's so simple. As I said, that's why it's only 1 mark. Okay. The next question is not so simple. And sometimes I know, especially in this AS level, we do it again and then it's very simple. Because then we do so difficult things there that this is simple. But it's good that we start in this level with this. Okay. It's write this in the form, but you must take note. This is an expression. Do you see it's an expression? Okay. We did completing the square. We solved quadratic equations, chapter 4, by completing the square. And I just want to see I first want to take you to that one, and then I'll come back. I'll take you to the textbook. I want to show you both. So I'm first going to start with, I first want to show you equations. That's expression. But I first want to show you in the textbook, on page 146, and that's equations, chapter 4. And that was where I was solving a quadratic equation by completing the square. Okay, so let's just keep first, I'm just want to refresh your memory on equations, and then I'll show you the difference. So if I go to this one, and it's an equation, then what I first did is I must make this 1x squared. So I basically just divide with 6 all the terms so that it's 1x squared. Okay, I took this constant term, I took it over, and that's what I got there. Now, it's almost like you create a space there and there. So what I'm going to try to do is I'm going to try to make this side a complete square. That means a bracket that's squared, and there's two things inside. Now, how do I do that? I basically just take this middle term, this 11 over 6, so 11 over 6, are you with me? The middle term, and I divide it by 2 and I square. So I divide by 2, okay, and then at the end I square. Now, if I divide by 2, it's going to be 11 over 6 multiply 1 over 2, which is going to be 11 over 12, and I square. And that's, if you look here, you can keep the sign. It's not going to, because a negative, it's a positive, so it's not going to have an influence. Okay. But what I basically do, because it's an equation, do you see that? I add that yellow on the one side, and I add it also on the other side, because I don't want to change the equation. I want to keep it the same. So if I add something on this side, add something on this side, I did not change the equation. Okay. Now, as I said to you, this is now a complete square. So that will create two brackets that's the same. So basically, I'm just going to take the square root of that x and the square root of that 11 over 12. And then you can either say, okay, it was that sign, but rather focus on that sign. So if that sign is a plus, then in the brackets is a plus. If it's a negative, in the brackets is a negative. And there's the square. Then I basically just go to my calculator and I just simplify this, and I got this. Okay. And then I just go and basically I'm just taking, I just want to see here, what did I do now here? So it was just, I'm just going to simply, I just take the square root, take the square root. Oh, I just showed you a step there because it's like, where is this coming now from? Okay. Okay, so basically I'm just going to take the square root on both sides. Okay, that's what I did. And then I'm just going to take that term over, do you see? And that's become a positive. So take the square root of each side, solve the two linear equations. And there I did that, and I got. So that was a way of also solving quadratic equations. You could have solved it by factorizing. You could have solved it with that lovely formula, the quadratic, minus b plus minus b squared minus 4ac. That is the one, divide by 2a. Okay, and actually this formula is coming from completing the square. By taking ax squared plus bx plus c and completing the square, then this was derived from there. Okay, so I just wanted to show you first the equation, and the part where I want to focus, and I'm just going to do this now. I'm going to clean, and I just want to make it bigger. I'm going to clean everything, do you see? And then what I want you to focus on is that I was just adding this extra. I add it to both sides because, as I said to you, it was an equation. Okay, keep that in mind. Let's go back. Not to the question paper. First want to take you now where it's in the textbook. The expression. Now, this is on page 250. It's still part 1, textbook 1. And this is now in chapter 6 because we use it in graphs. We can determine the turning point from this if we do this. So I put it in graphs. it's always good if you see where something is going to be used, and that's my whole idea when I create the books, is to make sense how everything fits like a puzzle. Okay, but let's start with this example. So this one I'm saying now to you, okay, I must say, write this in the form of this. Do you see? Okay, I'll show you now. It's actually expression. Hence, find the turning point and indicate whether it's a maximum or a minimum. Now, although this stands, can I just show you? I'm just going to take this expression, this, and take red, and I'm just going to put it in terms of that. So I'm using it as an expression. Okay. I think in the textbook I put there a y equals, but I don't seems like it came out so nicely. And now in my sketch, and it's fine. It's not going to have an influence. I just want to quickly check. It was, as I said to you, it was on page 250 in your textbook. I just want to see, because it looks like if you go to the textbook, yes. I don't know why it didn't come out. I think if I make it smaller, you will see it. Usually it's like that. No, it's actually not. It just didn't come out. Okay, but because if you look in the textbook, I just showed you, it was actually y equals. But I'm just using the one side and use it as an expression. Okay. The principle is the same as completing the square. Instead of dividing by that 6, I just took -3 because I still want to make it 1x squared. So I take -3 and I take it out as a common factor. So if I take it out, I divide, I get this. I divide, I get this. I divide, I get this. Okay, still the same. But because there's not two sides, I just must write it as a common factor. Then I do exactly the same. I want to create something there. I want to create my two brackets that's the same. I still take that middle term and I still divide it by 2 and I still square it. Do you see? And that's where I got there. Now, because it's not an equation, it's an expression, there's no equal sign, I'm going to add it. But if I add it, I must also subtract it so that it actually can cancel out if I want not to change the equation. Do you see? That's the difference which I want you to see. So there, so it's exactly the same as just subtract it. Now there, oh no, I want to keep it yellow. There is my two brackets, that's the same. So keep my -3 and I'm going to create now. There I just did it, I just simplified it a little bit. Okay, but can I just show you, it seems to me this also didn't, no, I think it's fine. I just want to show you this step here. So it's -3, okay. I sometimes prefer to put it just in a brick bracket. Let's just do it like this and make it x and make it +1. So I take the square root and square. Do you see? And then I'm sitting still with this that I'm just going to simplify. So it's -1, -1, and that will be -2. So let's just rather put it like that. I think it's going to be easier for you to see it there. And then after I did this, I'm just going to bring, there's a 1. So I'm just going to make it -3, x plus 1. I'm bringing that 3 in, but not in the bracket. Do you see? Just in front. And -3 times -2 is +6. And that is what I got there. Do you see that? And if I must then, just for the, it's not asking this question, the turning point will be different sign of this one. So it's -1 and that the same 6. And that is my turning point. And due to the fact that that was a negative, it's like this. So it's going to be a maximum point. Okay, but you can go and you can revise that. It was on page 250 in part 1 mathematics textbook, grade 10, 11, y equals mx plus c. Let's go. Now you're ready. Now you're ready to go back to the question paper. So the question paper becomes a little bit more challenging now. So the beginning it was really very easy, which is good because it's your first paper that you wrote here. Okay, so can you all see that this was an expression? It's not an equation, and they want it in that. They didn't ask turning points. They just want it in that form. Okay, So let's start. I'm going to rewrite it first for you. Okay. Then I'm going to take, it's not an equation, so I can just take a common factor out. So if I take my common factor, it's going to be x squared. If I divide, I'm going to get 2x. And if I divide, you can leave it negative 5 over 2. So let's just not make it a plus. Negative 5 over 2. Okay. Now I could have, okay, I'm just going to do it now. I could have 2. Okay, now let's see. It's still right. I can still keep the, I think I prefer this bracket. Now, I could have already just leave that space. After this one, I'm leaving this space. Then I say minus 5 over 2, and I'm leaving this space. Meaning that I'm going to add something here, and I'm going to subtract that same thing there. Okay. Now, what is that thing? That thing is I take that value, I divide it by 2, and I square. Okay, so you can already say this is just 1 square. So if it's, you can just write 1 square. But then you must also say minus 1 square. Okay, now remember what I said. That is your 2 brackets. That's the same. That you're just going to simplify. So I'm going to say 2, and I'm going to make my brackets, that's the same. I take the square root x, that sign plus square root 1 square. Now I'm going to simplify. So this is going to be negative 2 point, okay, let's just write it like this first, negative 1. That's fine. Now I said there's a 1. Don't bring it in, just multiply it there and simplify that and multiply it. So I'm going to get 2 x plus 1 squared. Now that is negative 3. Do you see? If I simplify that, it's negative 3 times 2. What is that? Negative 7. Magic. And that's my answer. 2x plus 1 squared minus 7. That's what they want. Just for the interesting, what would have been the turning point? The turning point would have been negative 1, negative 7. And it would have been a graph, no, I don't want to write there. It would have been a graph like that, with a minimum point. They didn't ask that. I was just saying that maybe for a next question paper. Okay. Okay, let's just go to the next page. Okay, matrices. That's now, we're more in book 2 now. We're going to move to book 2 now. So if you look at this one, oh no, this was vectors. Okay, so it's always like this. If you see that there's only one row, a column, that's the rows. You see there's only one column, it's vectors. As soon as you see there's more than one column, it's going to matrices. So it's given that the vectors find A plus B, and then find the magnitude. So again, I want you to take you to part 2, the textbook. And I'm going to take you to both. It's very simple, but still I want you to know where it is in the textbook. So let's just go to question 18. It's just showing you, but it's the same what we did with matrices. It's just how we're going to simplify add. So basically, if we add it, I just want to show here, we just add the same position. So 2 plus 3 is 5, negative 5 plus 2 is negative 3. As easy as that. Okay, so I think let's just go back to the question paper, and then let's just do that very easy one there. Okay, so just fill it in. I didn't show you now there. So in the place of A, it's negative 2, 7. And in the place of B, 8, 3. Okay, and then as I said, the same position. So 8 minus 2, 6. 7 plus 3, 10. And that's the answer, 6 and 10. Please don't make a stripe. Then it's a fraction. This is vectors. And you would have get a mark for that. What is that little stripes meaning, that little bars? It's meaning magnitude. So let's take again you to the textbook. And that is going to be magnitude, and that's 18b. Okay, let's just see where was magnitude. Where are we? We are in book 2, part 2. It's page 578, and we are at example 17, how to find magnitude. So if I look at this, express each of the vectors in a column, find the magnitude of the vectors. Okay, so there is A, B, and if I find the magnitude, I just square this one, and I add, and I square this one, and then I just take the square root. That is magnitude. It's coming from Pythagoras' theorem. Okay, so the same. So this one I square, this one I square, I add the result, and I take the square root. And that's all. So let's just go back to the question paper. I think that was a very nice, straightforward one also to you. And then it's just there. And you just had to know that that little bars is meaning magnitude. So then I just go A. And what is A? I just go, okay, remember there's A. So it's negative 2I square, 7I square. And then I just get 2 times negative 2, it's 4. Plus 49, and that is square root of 53. You could have leave it like that, or you could have pressed it on your calculator, correct to three significant figure 7.28. Just want to make double sure. Yes, they said you can either write it to them in this form, or you could have write it to three significant figures. Okay, and it was 2 marks, so the other mark you would have get for putting it there, that method mark. And then the last question on this page, write as a single logarithm. This is logs. Okay, chapter 5. So let's just go back to the textbook. It's in part 1 that we are back at, and this is question 19. And this example is 25. Okay, now you just had to know your log rules. Okay, so please just know your log rules. And as I said, it's almost like the reverse of indices. So reverse is always a bit more challenging. So just think of if you go for a driver's license. So let's just look. Now I just want to show you if you cannot use the laws. Now I just want to quickly see what page was that. It was on page 199. I just want to refer to you to the laws. I didn't write the laws for you. It's the quotient law, that's the division. I just want to see, you can actually just go to the summary and see all the different laws there. Okay, just want to see, and I think the best will be to go in the summary. That will be the last page of chapter 5. There at the summary, and that's on page 224, you would see the laws. The product law, the quotient law, and the power law. Okay, I'll tell you as soon as I come to one. Now, in this case, you first should have create a log there. Now, because in grade 11, you just do with a base of 10. So you can log 10, 1 will be log 10 because it's 10, 10. 2 will be log 100. Okay. 3 will be log 1,000. 4 will be log 10,000. Do you see that? So in this level, and because it's so new to you, I think it's good if you just at least memorize that. Okay, because it's going to help you. So basically, I'm just going to, in the place of 3, I'm going to write log 1,000. And now I'm going to follow the laws. The quotient law. Now, the quotient law is when you see subtraction, and that goes into a division. But just a very simple way of saying it. But when it's subtraction, then you write 2 log words are there. But as soon as you write it as a division, there's 1 log word. And then just that number, 60 over 1,000. So if you're going to write log 60 divide log 1,000, you're going to get 0 marks. That's incorrect because there must just be 1 word. Okay, so please, it's just a simple way of saying it, but make sure that you don't make that mistake. And then I simplified. I made it a single logarithm. And that's what they want there. Okay, so let's just go to the question paper. Let's see the question paper. Okay, let's just see, it was maybe that one. Okay, so if I'm going to look here, now again, this one, I'm going to follow the rule. And can I just show you? You remember that we had this, say it's 2 log A Okay, I can write it as log A2. It's that jump up. It's either there in the index or in front. And that's the power law. And that's what I'm going to do there. I'm going to jump up that one. That one I'm going to create a log word. So let's just start. So if I want to just rewrite it, I can say 3 log x plus 7 plus 1 minus log x. So I'm going to have log, and then it's x plus 7. And now I'm going to do that power law. I jump that one up. Do you see? That's very important. There I create a log word. I said 1. What can you still remember what was 1? That was very easy. That is 1, 0, so it's 10. What is this one? That one is fine. So please, again, it's like algebra. Put in steps. It's going to help you. Now, the ones that's you're going to follow the product law. Okay. That means you're going to write one log word, and then it's going to be x plus 7, 3 over 10. Okay, I'm not going to... Oh, sorry. Sorry. I didn't concentrate now. That's not product, that's quotient. It's going to be 10 x plus 7, 3. It's meaning you're going to multiply. Plus goes to multiply. Subtraction goes to the quotient law, that goes to division. So then it's one log word. Remember there was 2, but then it's 1. Quotient, one log word, and then it's going to be 10 x plus 7 to the 3 over x. Okay. Now, I see that they said you could have multiplied. Oh, please don't waste so much time. That was the final answer. The final answer was log 10 x plus 7. Just my pen, sorry. And that's over x. Okay, but if people multiply it out, and I'll show you now the answer, they would have been correct. Can I just show you? You can, what I usually tell is you can go directly from this step. You can go directly. So you could have said the ones that's where there's addition, I write next to each other. And the one where there's a subtraction, I write under. So you could have already, you could have already write that one log word. Then the ones that were addition, then you could have write next to each other. And the one that was subtraction, you could have write at the bottom. And you would have directly go into that. Now, but if somebody wrote this, you multiply out, it's going to take you so much time, and it's not necessary. It's not going to give you extra marks. I just see it in the memo. So if someone go and he went to this and he wrote this, it will also be correct. But as I said, just stop. Again, I think that will, if you come to up to that step 2 marks in the final, you will get that 1 mark.